This is a video for section 2.6, and in this video we're going to go over how to do a squeeze theorem problem. These problems are really difficult and are really tricky, but hopefully this video, after we go through it, will kind of give you a step-by-step guide of how to approach these problems. So this is number 11 in your book. It's the limit as t approaches 0 of this function here. Okay, so first, before we start solving this problem, let's go through what squeeze theorem says and go through the book definition, and then as we solve through this problem, we'll mirror it with this definition, and hopefully everything will kind of come together and make more sense. All right, so the book tells us that if the function we're interested in, which is f of x, is in between two other functions, so there's this function on top here, this function on the bottom, and the function we're actually interested in is always in between those two functions. Okay, we have that set up. And then it tells us, well, if the limit as x approaches c of one of those functions, so as the top function is going to some value, if it has the same limit as what the bottom function is going to, so as you see here, the top function is going down to this value, I called it L, and the bottom function is also going up to that same value L at the same x point C. So at C, both functions are approaching L. And remember, we said that the function we're interested in, this green one, is always in between those two functions. Well, then that means that the limit as x approaches C of the function we're interested in, of f of x, must also be equal to L. Since it's always in between the top and bottom functions, it must also have that same limit if that's where both the top and the bottom functions are going. So this is useful if we weren't able to solve for the limit as x approaches c directly of f of x. We could put it in between two functions where we do know that limit, and since we already have this condition that this function is always in the middle of those two functions, then we're able to say by deduction, well, if this function and this function are approaching the same L value at C, then this middle function must also be approaching that same value since it's always stuck in the middle. Or in other words, since it's squeezed at that point x equals C, must have the same limit. Okay, that's the background. Let's go through this problem now. All right, so it's a limit as t approaches 0 of 2 to the t minus 1 times cosine 1 over t. Only difference between this and this is that we don't have two functions given to us that this thing is bound between. So that's what we need to do. We need to come up with what this function is bound between. Okay, so looking at this function, a way to go about doing this is to think, well, is there a part of the function where if I were to plug in a value, it wouldn't work? Or is there a part of the function where it has a defined maximum and minimum value? Okay, let's look at this first part. If I have 2 to the t minus 1, does that have any limit? Not really. I can plug in any value I want for t, and this number could be super huge, it could be super small, it can be any number that it wants to be. Okay, that was unhelpful. If I go to the second part of the function, cosine 1 over t, is that function bound by anything? Well, if you think to what the cosine graph looks like, or if you think back to your unit circle, the most cosine can be as positive 1, and the least cosine can be is negative 1. So the function cosine actually does have bounds. It's bound by negative 1 and positive 1. So that's where we're going to start. Let me use the same color. So my lower bound here is negative 1 is less than or equal to cosine 1 over t, which is less than or equal to positive 1. Okay? So I just took my cosine function, put it in the middle, because I know that no matter what this inner angle is, cosine can never be bigger, or can never be less than negative 1, and can never be more than positive 1. And just a pro tip with these types of problems, if you ever have a trig function with a squeeze theorem problem, that's probably where you want to start. Because remember, both cosine and sine are bound by positive and negative 1. All right, so I have cosine 1 over t is bound by these two values, but I'm not really interested in just cosine 1 over t. I'm interested in this entire thing over here. So how do I make this look like that? Well, I can multiply each part by what I'm missing, by the 2 to the t minus 1. So I'm going to multiply every part in here by this thing. So multiply everything by 2 to the t minus 1. Over here, I'm going to get minus times 2 to the t minus 1. Distribute this negative 1 to everything. So I get minus 2 to the t plus 1. is less than or equal to, in the middle here, I just have my two terms, which is what I want because remember, this is the function I'm interested in. Now I have the function here. And on my right, I get 1 times this value, which just leaves me with 2 to the t minus 1. Okay, now we're getting somewhere. Now we have two functions that the function that we're interested in is bound between. Okay, but remember this question is asking us to find the limit as t approaches 0, which we weren't able to do initially, but now that we have these two functions, we're able to solve for what that limit is. So remember, going back to our definition here, our function of interest is bound between these two functions. If I can find the limit as x approaches c of those boundary functions, I'm able to find the middle limit. So let's start with this side here. I'm interested in the limit as t approaches 0 of this, so negative 2 to the t plus 1. If I were to just do direct substitution, plug in 0, I get negative 2 to the 0, which remember is just 1, plus 1. That gives me 2. Except I lied. This should be negative. So negative 1 plus 1 should actually give me 0. And on the outer function, I'm going to do the same thing. Find the limit as t approaches 0 of 2 to the t minus 1. Over here, I get 2 to the 0, which is 1, minus 1. That gives me 0 as well, which is what I should expect, right? Because over here, we wanted two functions that converge at the point x equals c into the same limit, so that now, since these squeeze together, and since I know that this function is always in between these two functions, now, by deduction, I know what the limit of this middle function is as well, right? So my lower bound is going to 0. My upper bound is also going to 0 when t approaches 0. So because of that, I know that the limit as t approaches 0 of this function that I started with, 2 to the t minus 1 times cosine 1 over t, must also be 0. And that's it for this problem. Brief recap of everything that we did, so you kind of have more of a step-by-step way to think about this. When we first have our problem, the first thing we want to look for is what part of our function has bounds. Which part is bound by something? It can't be more than this, can't be less than this. A lot of the times, it's going to be a sine function, either sine or cosine, and that's always bound by negative 1 and positive 1. And then from there, I just made whatever I had here match what I started with. And I had to do that by multiplying everything by 2 to the t minus 1. When I did that, I finally had in my middle the function that I started with, and I had two functions that I was bound by. From there, I just looked to see what was the limit, or what is the limit as t approaches 0 of both my lower and upper bounds. And it was the same value, it was 0. So I'm able to say that of my middle function, the limit as t approaches 0 of my middle function is also 0. And that's it for this problem.